In NCEA Level 2, you learned how to differentiate basic polynomials in this form here. Fx equals a x power of n, where a is just some sort of constant. It's a coefficient. And you learned that f dash x, or the derivative of this function, is you bring the power in front, you multiply by any coefficient in front, and you reduce the power by 1. Now in level 3, we're going to show you that this rule works for any n. It could be negative, it could be fractional, or it could be just a whole number. So for example, number 1, really basic, y equals x to the power of 7. Now if you've got y, we like to see dy, which basically says differentiate y in terms of x, so dx equals x, bring the 7 in front, and reduce the power by 1, so 7x to the power of 6. Now if we have something like a square root, well, we need it in the indice form. So firstly, we're going to rewrite our square root as x to the power of 1/2. Then, once it's in this form, we can now differentiate f dash x, bring the half in front, and reduce the power by 1. Now, if you have a negative power and you want to move forward to a harder question that uses this to solve, it's easier if we simplify this by bringing the x to the bottom of the fraction. Now, currently, when it's beside a fraction, this could be rewritten as x to the power of negative 1/2/2. So any number that's multiplied by a fraction goes to the top. And we could rewrite this by bringing the x to the bottom by rewriting this as 1/2 x to the power of half, which if we wanted to write it in the original form, which had the square root, we would write that as 1/2 square root x. Now, third question, we've got 1/x. Now, this is not in the polynomial form that was above. It needs to look like that. This is 1/that. So the first thing we're going to do is bring our x to the top by rewriting it as x to the power of -1. So whenever you have a power and you bring between the top and the bottom of the fraction, just like in the previous question, if you bring it to the top or bottom, you change the sign of the power. Then we can differentiate f dash x equals, bring the negative in front, so it's negative x to the power of reduced by 1, -2, which we could rewrite this as -1/x to the power 2. Now, we can also apply these rules to a stacked polynomial, so one which has lots of plus or minus in between. We're just going to differentiate all of these terms individually. But before we do that, we need everything to be in the form that can be differentiated. In this fourth question, the 4x to the power of 5 is fine, the x is fine, the -2 is fine, but this 2/x needs to be changed to plus 2x to the power -1. Then we're going to differentiate, bring the 5 in front, times it by 4, we get 20, and reduce the power by 1. X differentiates to just 1, -2, any constant differentiates to 0, and finally bring the power in front, so we get -2, reduce the power by 1, x to the power of -2, which I'm going to rewrite as 20 x to the power of 4 plus 1 minus 2/x to the power of 2. When you move the variable to the top or the bottom, just move the variable, don't move the coefficient. Number 5, we'll use that same trick there. We're going to bring the variable up, only the variable. So this is the same as 5x to the power of -3/2. Now we're going to differentiate. Bring that -3 in front, we get -15. Reduce the power by 1 to the power of -4/2, which we can simplify to be -15/2x to the power of 4. Again, the numbers are staying where they are, only the variable is moving between the top and bottom of the fraction. Finally, question like this, need to set this up before we do any differentiating. 3x squared is fine. The cube root of x can be written as x to the power of 1/3. 2x is fine. And bring the x up to the top as before. 3x power negative 1 over 4. Now we can differentiate. We get 6x plus 1/3 x to the power of, now a third minus 1 is negative 2/3, plus 2. Then we bring that negative in front, it will cancel with the other negative sign to make a plus. 3x to the power of negative 2 over 4. And then rewriting this in a bit more simplified form, we can bring the x to the power of negative 2/3 to the bottom of this fraction by writing it as 1 over 3x to the power of 2/3 plus 2. And same with this x to the power of negative 2. Bring it to the bottom of the fraction, we get 3 over 4 x to the power of 2. Now, if you wanted to write this in its original form, we can finally write this as 6x plus 1 over 3 times the cube root of x squared plus 2 plus 3 over 4 x squared. Now, it's really important that we know our surd rules, and so make sure that you do know that if you have something in the form the nth root of x to the power of m, that's the same as saying x to the power of m over n. Finally, you may get a question that looks harder than it is. For example, you might get something like x squared minus the square root of x to the power of 3 plus 1 all over x. When you're something like this, the best thing to do is to split this up. We could write this function as x squared over x minus the square root of x cubed over x plus 1 over x. We can then simplify this. X squared over x is just x. We can't quite simplify this next term yet. We have to change this to x to the power of 3 over 2 over x plus, and 1 over x to be differentiated needs to become x to the power of negative 1. So finally, tying up this middle term, x minus x to the power of 3 over 2 divided by x. Well, rules of indices say when you've got the same base, you subtract the powers when dividing. And so we get x to the power of 1/2 plus x to the power of negative 1. Now differentiating, x becomes 1. Middle term becomes 1/2 x to the power of negative 1/2. And final term becomes minus x to the power of negative 2. Simplifying, we get 1 minus 1 over 2 x to the power of 1/2 minus 1 over x to the power of 2. And rewriting this in its original form, we get 1 minus 1 over 2 square root x minus 1 over x squared.